Welcome to Hints for Project 22, the unit circle. Let's just quickly review some of the important facts here. One, it's a 16-point project. It's due on Tuesday, April 16, 2013 at 4:15 p.m. This is something new. I will not be available for help on this project on Tuesday, April 16th. You need to plan ahead. You need to have this finished, or at least extremely close to being finished, by Monday, April 15th. Okay, so there's 4 parts to this project. All of them have to do with kind of prepping you up for pre-calculus. The question is asking you to find the coordinates of basically 16 points around a circle coinciding with 45, 45, 90, and 30, 60, 90 triangles. There'll be directions above for each part. For this one, measure of angle AOB is 30 degrees. So angle AOB is 30 degrees, circle with center O. There's no O there, but this will be circle with center O. So angle AOB is 30. So what can I do you think, to find the coordinates of B? If I drop down in altitude from B? What if I drop down in altitude from B? What have I created? What have I created? So let's review our 30, 60, 90s and 45, 45, 90s. So for 30, 60, 90 triangles, remember the hypotenuse is always opposite the right angle. We're going to call the side opposite the 30 degrees the short side or short leg. The side opposite the 60 is the long side or long leg. So the relationship is, let's say that we are given the short side as x. If the short side is x, the hypotenuse is going to be twice as big, or 2x. The long side is going to be radical 3 times as big, or x radical 3. So that's the formula. You're going to need that in your pre-calculus and calculus careers. You need to know that relationship. Okay, so for example, if I have a 30, 60, 90, and let's say the hypotenuse is 5. If this is the short side over here, x is going to be half as big, and the long side is going to be radical 3 times as big. For this project, you're supposed to leave everything as an exact value. Leave it in radicals. I don't want to see decimals. Leave it in fractions. Leave it as radicals. All right, so now, if we go back to the project itself, you will notice that I am also going to have 45 degree angles. Angle AOC is 45 degrees. So we have to also recall our 45, 45, 90s. So 45, 45, 90s are also called right isosceles. So the 2 legs are equal. So x, x. If you were to use Pythagorean's theorem, you would end up with x radical 2. So 4, 4, 4 radical 2, or 5, 5, 5 radical 2. Okay? What happens if in a 45, 45, 90. The hypotenuse is an odd number. All right. There was sort of a trick we learned in the right triangle chapter, and that trick is you're just going to take half and multiply it by radical 2. So if the hypotenuse is 5, the leg is 5/2 radical 2. Okay, hopefully that's a helpful reminder on how to find your two special right triangles. Remember, when you're on the project, you got to remember what quadrant you're in. So if I'm going to find this point right here, I have to go over negative some quantity and then up. So it's going to be negative and positive. Thank you for looking at this video.